Welcome to IoT and Mobility's Lab 1, Understanding IoT File Systems. This Understanding IoT File Systems lab will explore the features, facets, and inner workings of IoT and mobility. This lab's focus, static firmware investigation. Before proceeding to this lab, we must perform the compulsory reminder about lab safety. Use only tools with non-conducting handles when working with devices. Do not use or store highly flammable solvents near electrical equipment. All current transmitting parts of any electrical device must be enclosed. Treat all electrical devices as if they are alive. When checking an operating circuit, use one hand to avoid closing a circuit through your body. Drain all capacitors before working near them or trying to remove the capacitors from service. Never change wiring on a circuit board plugged into a power source, period. And finally, when working in a lab, no jewelry, metallic pencils, rulers, or wearing rings or metal watch bands, for obvious reasons. And now the objectives of this lab. Any IoT device you use will be interacting with firmware, and this is because firmware can be thought of as the actual code that runs the IoT or embedded device. This lab's objectives could be summarized simply as a guide to understand how to perform a static investigation on firmware using binwalk. The objectives of this lab are, but are not limited to, the following. The first objective is to understand how to investigate an extracted firmware file and collect valuable data about it. Next, to learn how to analyze an extracted firmware if it is in fact a binary file. Also, learn how to use strings command to extract information from a binary file. And finally, learn how to look up various critical components and even the password of the firmware. And now lab resources. This lab requires VirtualBox virtual hosting system and Kali Linux guest host operating system. And for extra lab files, please download the file firmware.bin from your Canvas application. Now, the task portions of this lab. Lab Task 1. In this task, you will investigate an extracted firmware file and collect valuable data about it. Start with the Kali VM and then open the Downloads folder. And that's it for this task. Task 1 is now complete. In Lab Task 2, they want to take the bin file that you've acquired into the Kali system and actually drag it over to the download folder. There are two possible avenues here. One is use the facility of a shared folder on the Oracle VirtualBox system for your particular virtual guest OS, or you can email it to yourself on the system, which both you, your host system, and your virtual system have access to. Either way, it's in wherever it landed, and now you take that folder and drag it over to the downloaded folder, and that concludes basically Lab Task 2. Lab Task 3 asks us to open the terminal by clicking the icon in the options bar. In my case, the option bar is up here, and I click the terminal and center it out. And that completes Lab Task 3. Lab Task 4 asks us to navigate to the Downloads directory using the command cd downloads / and that completes Lab Task 4. Lab Task 5 will ask us to use the strings command onto the binary file. And I would want to take this moment real quickly to let you know that different types of IoT devices have different types of firmware formats. And sometimes you'll run into an ASCII, binary, hex, or whatnot, and you just need to be aware of the context of your file you're working with. Is it on RTOS? Is it on Linux or bare metal? And I thought it'd be important just to let you know, not everything is in a binary format. And so some of the formats you'll run into, like Motorola S Record, known as SREC, would look like this. And just note that this file format is a hexadecimal. And then there's the Intel hex, which is similar to the SREX from Motorola. And Intel hex lines all start with a colon, like this particular graphic. And then, of course, there's Texas Instruments format, usually for the SP430 series. And memory addresses are appended with an @ sign, right, like this. But that's not the case in this lab. This lab, we actually have a binary. So the strings utility that we're going to use on it displays strings of a printable character found on specific files. These strings are at least 4 characters long and must be terminated by a null character or a new line. So if you specify a file name or no name at all, strings will read for the standard input or read from the file depending on what situation it stands. This utility finds interesting pieces of information in binary files. It frequently is used for looking through executables to uncover copyright notice, error messages, undocumented features, and so on. So here we are at Lab Task 5, and our mission is to perform the strings command on the file firmware.bin that's in the downloads directory. And so just to make sure, there's ls, there's the firmware bin. So they would like us to type in strings firmware.bin. Now, this is a big file, so it's going to paginate really fast and quickly and go right to the end of the file. I prefer to pipe that. This is a pipe. In other words, redirect standard out to a pagination function called more. In other words, you may have seen this in the Linux class, or in your experiences with Linux or Unix. This is the ability to just pipe it page by page. And this is the first page of the file. And that concludes task 5. Task 6 asks us to use the command again, strings firmware.bin, but coincidentally, they ask us to pipe it to grep. And as we did it with more to paginate, they are asking us to use grep. And grep, for those who aren't aware or haven't experienced using it before, is a string search facility for a particular argument, in this case, of U-boot in the file firmware.bin. So it'll search that out and produce in standard output the result and giving us not only the version, but the date it was updated. And for those of you that are not familiar, U-boot is an open source bootloader found in many embedded devices in the IoT world. Much like the MBR in Microsoft, if you remember from your Microsoft class, or Grub, that was the bootloaders for particular hard drives. Anyways, that is what they're looking for. And so we hit return, and there it is. In the firmware.bin file, we find U-boot, and the line there tells us the version of 1.13 and when it was updated at December 13th, 2018. And that concludes our task 6. Task 7 asks us to use the same command, strings firmware bin. In this case, we'll up arrow in this here, and we have the same command, but we'll just get rid of the pipe more, and then we'll redirect, as they instruct in the lab, to a file name they call strings underscore from underscore firmware. And that will pass the commands strings firmware and pass it to the file name strings from firmware. And so that's what it is, just redirecting the output from standard out to a file, and that concludes task 7. Task 8 asks us to run the ls command to verify that the file was created. And as you see here, strings from firmware has been created by the command that we did beforehand, which was the redirection of the strings output from the firmware.bin. And so that is the file that we did. And that concludes task 8. Task 9 asks us to use the command nano to the binary file that we created with the redirection. So here, and let's do ls to remind us the exact spelling, nano strings underscore from underscore firmware. And that brings us to the exact file, and that concludes task 9. Task 10 asks us to identify the MAC address in the file and use it to identify the manufacturer of the device. So we first would use nano to get a search, and that's Control W in nano. So let's Control W, and we would type in the Ethernet address at ETHADDR is what we're searching for. We search, and there it is, the MAC address. We select the MAC address right here in without the quotes. We copy the selection, and then we go over to, so task 11 says search for the file for the protocol used by the device. So in order to do that, we hit Control W again, and we search for a different term. In this case, boot CMD equals. And boom, it takes us right to the protocol used by the device, which is Trivial File Transfer Protocol. And that concludes task 11. Task 12 asks us to search for the device's baud rate. That is just Control W again in the nano, and we put in the search term baud rate. And I'll put in the equal sign to make sure we get to the right one, just in case there's another instance of it. And that brings us right here, and the baud rate happens to be 115200. So there it is. And that ends task 12. Task 13 asks us to search for the device's IP address. And once again, we go to nano and then Control W for the search. And we'll be searching for, this term is IP ADDR, and equals, and we'll hit enter, and there it is. It's right in front of us, or just below the ether address, the MAC address, is the IP address, 192.168.0.2. And that concludes task 13. Task 14 asks us to use the command binwalk on the file firmware.bin and note the file system used in the device. So we're here back in nano still, so we have to exit out of that, Control X. And that'll get us out there. And so now we will type in the command bin walk, binary walk, firmware.bin. And then from there, you will see that we have identified the file system to be squash file system, squash FS. And that will complete task 14. In task 15, they ask us in the same output, to identify the compression algorithm. And if you'll notice here, just above the file system, which is squash file system, the compression algorithm of choice is LZMA. And that concludes task 15. For task 16, they ask us to use the command again, but this time with the options lowercase e, capital M, to the firmware.bin file to extract the firmware. So just understand, first, the binwalk command, lowercase e means extract, and the lowercase m means recursively scan extracted files. So that's what we're doing here. We're talking binwalk, lowercase e, capital M, space, firmware, this is the file we got from extra files, .bin. And that produces a file that extracts the actual firmware. And that concludes task 16. In task 17, they say use the ls command and note the new directory that's been created from the extraction, and the folder is underscore firmware.bin extracted. That concludes task 17.